radicals. So radicals is really the new concept here in 5.7, or in 7.5, sorry. And a radical is essentially the opposite of an exponent. So first of all, let's look at the parts of a radical. So parts of a radical here, the number out in front of your radical, the n value, is considered your index. Okay, that is what you are taking the radical of. Obviously, this symbol out above our a there is just our radical symbol. All right, and the number underneath your radical is called the radicand. That is the number you are taking the radical of. Okay, a note here. If there is no index, it is assumed to be a 2, or we call that a square root. Okay, another note here. If a radical has more, that's supposed to be than, so has more than one root, the radical sign only indicates the principal or a positive roots. Okay, so when you're working with radicals, you know that you're working with positive roots. It's implied. All right, so the next section down here, so before we look at square roots in particular, it's really good to go over the perfect squares because that is how we are going to simplify our square roots. So let's just go over our perfect squares quick. 1 squared is 1, 2 squared, or 2 times 2, which is 4, 3 squared, 3 times 3 is 9, 4 squared, 4 times 4 is 16, 5 squared, which is 5 times 5, is 25, 6 squared, which is 6 times 6, is 36, 7 squared, or 7 times 7, is 49, 8 squared, 8 times 8, 64, 9 squared, 9 times 9 is 81, and 10 squared, 10 times 10 is 100. So each of those values that I just wrote out as our perfect squares are values that you can simplify with a square root. So for example, if I was to take the square root of 4, I would get 2. Okay? Taking the square root is just the opposite of squaring. So let's go over just a couple of examples. So first of all here, if I take the square root of 81, I would think the perfect square for 81 would be 9 squared, which is 9. So the square root of 81 is just 9. All right? So for an example like this, where maybe you are unsure if it's a perfect square, or we haven't gone up to that example, you can, either work it out by hand, or if you were able to use a calculator, you could do that too. So first of all, let's think about what's a perfect square that we know that is close to 484. So we're going to do our workup here. So the first one that I can think about is, what's 20 squared? What's 20 times 20? Well, 20 times 20, 2 times 2 is 4, with 2 zeros. 20 squared is 400. I know that on the top of my head. Okay? So obviously, 400 does not get me to 484. So I'm going to have to keep working my way up. So how about 21 squared? Okay, 21 times 21. I could work that out real quick. So 21, oops, 21 times 21. 1 times 1 is 1, 2, 2, 4. So 21 squared is going to give me 441. That's not quite 480. So before we try to simplify, let's also try 22 squared. 22 times 22. Let's see, we've got 4, 4, 4, and 4. So that's going to give me 484, which is perfect. So we know that if we take the square root of 484, that we are going to get 22. So 484 is a perfect square. It's just not an easy one to notice. All right, let's scroll down and do some of these examples. So I have 18 times the square root of 4. So we are going to simplify our square root and then multiply it by 18. But 18, the square root of 4 is just 2. So this gives me 18 times 2, which is just 36. All right. So I've got 3 times the square root of 256. Once again, I don't know that one on top of my head, so let's take a guess. So I do know 15 squared on the top of my head, which is 225, so we're getting close. So how about I try 16 squared? 16 times 16, 6, well 36, carry the 3, 6, 9, 0, 6, 1. So I've got 6, 5, 256. Perfect. So I know 16 squared is 256. So the square root of 256 is just going to give me 16. So I've got 3 times 16, which just equals 48. All right. So in the next section here, we are taking the square root of fractions. So just like when we are taking power to a power of fractions, with the square root, you can break it up with your numerator and your denominator. Okay? Simplifying both of these, the square root of 1 is just 1. The square root of 16, 4 squared is 16, so that is just 4. Okay? Same process with this next one. Let's break it up. Square root of 9 over the square root of 100. What times itself gives us 9? Well, that's 3. Square root of 100 is just 10. All right? So that is a quick introduction to square roots and radicals. Let's take a look at the back side to look at non-perfect squares. So all of these are perfect squares. They simplify really nicely. On the back page here, we are going to look at non-perfect squares. So please write this down somewhere in your notebook, and I'm just going to read through it real quick. So the first thing you want to do is find the largest perfect square that the radicand, so the number underneath the radical, is divisible by. Then we're going to break apart the radical, one of those numbers being the perfect square and one being the corresponding number. Let's take the square root of the perfect square to simplify it, and then we leave whatever is left over under the radical sign. So obviously, this is going to take you guys some time to write down. Take your time. Please pause the video to write it down. All right. So looking at the examples here, so whenever I'm simplifying radicals, I do find it helpful to write down the perfect squares. So just writing them down, I've got 1, 4, 9, 16, 25, 36, 39, 64, 81, 100. I could keep going further. 121, 144, 69, 196, 225. So I went a little bit overkill with this. Typically, you would not need to list this many, but it is totally up to you. Use your calculator to help you. 1 times 1, 1 squared, 2 squared, 3 squared, 4 squared, right? Use that to help you guys write these down. So the first thing here is I'm thinking about what's a perfect square that I can use to simplify the square root of 24. So obviously the square root of 24, 24 is not a perfect square. So I'm going to start just below 24, which would be 16 would be my first number. 24, 16 is not divisible by 24. Next one, 9, not divisible by 24. Oh, but how about 4? 4 times 6 gives me 24. So that's how I'm going to simplify this. So I'm going to split 24 into 4 times 6. From here, if you wanted to, you could break up your radical. Totally up to you if you need to do that step. And now let's simplify. The square root of 4, we know is just 2. We can't take the square root of 6, so that's our leftovers. 2 square roots of 6. All right. Let's also try the square root of 48. So 48 is below 49, so let's start working our way down the list. 36, not divisible. 25, definitely not divisible. How about 16? 16 times 3 is 48. So let's break that up. 16 times 3. If you guys wanted to, you could break these up. The square root of 16, we know is 4. And we can't take the square root of 3. So we're just going to leave it. Okay, let's just do one more example here. Let's take the square root of 63. So 63 is below 64. So let's start working our way down the list. 49, no. 36, 25, 16. You might want to check 16 in your calculator, but I think 9 is the first one that I know is divisible by 63. And remember, you can always do this multiple times if you need to. So I know that 9 times 7 is 63. 7's a prime number, so we're doing well. So I can split this up, square root of 9, square root of 7. Square root of 9 is 3. And I can't take the square root of 7. So I'm going to simplify this as 3 times the square root of 7. All right, I lied. Let's do one more example. The square root of 90. So the square root of 90, thinking about all of these here, my attention immediately is drawn to 9. Because I know 9 times 10 is 90. Let's use it. Put this into 9 times 10. I can go ahead and split my radicals. Square root of 9 is just 3. And I can't take the square root of 10. All right, so that should be enough examples to get you guys started on these type of questions, simplifying non-perfect squares. Please try a couple of the other ones on your own just to see if you can work your way through the process. But regardless, we will go over these to start class. Please bring any questions that you guys have. Thanks for watching.